Yai Hind, everyone I am from Indian Space Team PR Department. Have you ever wondered how we came to know so much about the geography of Mars, a planet millions of miles away from us? Our journey into the Martian landscape begins in the early 19th century with pioneers of areography, Johann Heinrich Madler and Wilhelm Beer. These two gentlemen are best known for their meticulous lunar mappings, but it was their work on Mars that set the foundations for our understanding of the Red Planet. Madler and Beer began their Martian exploration by establishing that the majority of the planet's surface features were permanent, debunking the idea of a constantly changing Martian landscape. Their keen observations also allowed for a more precise determination of Mars's rotational period, a fundamental aspect of understanding any celestial body. But perhaps their most significant contribution came in the year 1840. After a decade of careful observations, Madler combined all their findings and drew the first map of Mars. This was an extraordinary achievement, a testament to their perseverance and meticulous diligence. It was the first time that humanity had a detailed reference of a planet so far away, a guide to the alien landscapes waiting to be explored. Their map was more than just lines and shapes. It was a door to a new world, a world that held the promise of countless discoveries, and potentially the answers to some of our most profound questions. It was a world that was now within our reach, thanks to the tireless efforts of Madler and Beer. Their work laid the groundwork for all future Martian explorations. It guided the path for countless astronomers, scientists, and explorers who would follow in their footsteps, seeking to unravel the mysteries of the Red Planet. With their map, we were no longer blind explorers in an alien world, but informed travelers with a sense of direction. And thus, the first steps of understanding Mars's geography were taken, setting the stage for future explorations and discoveries. Ever wondered who names the features on Mars and how they choose these names? Our journey to Mars begins with albedo features, which are named after characters from classical mythology. These are the lighter and darker areas on Mars, traditionally thought to be continents and seas. But as our understanding evolved, so did the names. For instance, Nix Olympica, meaning the snows of Olympus, was updated to Olympus Mons, or Mount Olympus, when we realized it wasn't snow we were looking at, but the largest volcano in the solar system. When it comes to naming craters, there's a bit of a size rule. Craters larger than about 30 miles are named for deceased scientists, writers, and others who have contributed to the study of Mars. This is our way of honoring those who have dedicated their lives to understanding the Red Planet. Smaller craters, on the other hand, are named for towns and villages of the world with populations of less than 100,000. This gives even the smallest places on Earth a claim to fame on Mars. Valleys, too, have their own naming conventions. Large valleys are named for the word Mars, or star, in various languages, while smaller valleys take their names from rivers. This is how we find features like Valles Marineris, the Mariner Valleys, named after the Mariner 9 mission that discovered it. The plains of Mars, covered with dust and sand rich in reddish iron oxides, have names like Arabia Terra, the land of Arabia, or Amazonas Planitia, the Amazonian plain. These names were chosen to reflect the perceived similarities between these Martian features and their earthly counterparts. And lastly, the polar ice caps. The northern cap is called Planum Boreum, while the southern cap is Planum Austral. These Latin names translate to the northern and southern plains, respectively. So each name on Mars is not just a label, but a story, a tribute, or a reflection of our earthly languages and cultures. Just like Earth, Mars too has an equator and a prime meridian. But how were these defined on a planet without a sea level? Determining the equator of Mars was straightforward. It's defined by the planet's rotation, just like here on Earth. But defining the prime meridian, the zero longitude line, was a bit more challenging. This imaginary line had to be arbitrarily chosen, just like it was on Earth when Greenwich was selected as the prime meridian. Back in 1830, the astronomers Johann Heinrich Madler and Wilhelm Beer selected a line for their first maps of Mars. But it wasn't until the spacecraft Mariner 9 provided extensive imagery of Mars in 1972 that a small crater, later named Airy 0, located in the Sinus Meridiani, or Middle Bay, was chosen by Merton Davies, Harold Masursky, and Gerard de Vaucouleurs as the definitive 0.0 degrees longitude line. This selection coincided with the original choice made by Madler and Beer nearly a century and a half earlier, so we've got an equator and a prime meridian. But there's another challenge. Mars doesn't have oceans or a sea level, so a zero-elevation surface had to be selected as a reference point. This surface is known as the areoid of Mars, similar to Earth's geoid. In order to define this zero altitude, scientists used a specific atmospheric pressure as the benchmark. They chose the height at which there is 610.5 pascals of atmospheric pressure. This pressure corresponds to the triple point of water, where it can exist simultaneously as a gas, liquid, and solid. It's about 0.6% of the sea level surface pressure on Earth. In this way, despite the lack of oceans and a sea level, scientists have been able to create a reference system on Mars. This has been crucial for our understanding of the planet's geography and for planning missions to the Red Planet. This is how we've managed to create a reference system on Mars, despite its lack of oceans and sea level. Opening. To make Mars's vast and varied geography more manageable, it's divided into cartographic quadrangles. But what are these exactly? Well, imagine taking a complex puzzle and breaking it down into smaller, manageable pieces. That's essentially what cartographic quadrangles do for the geography of Mars. The United States Geological Survey took the initiative to divide the Martian surface into 30 distinct quadrangles, each named after a classical albedo feature it contains. This division is not random. Quite the contrary, it's a systematic approach designed to make the study of Mars's geography more detailed and systematic. Each quadrangle is a specific region of Mars's surface, with its unique set of features and landmarks. Now you might wonder, why 30? Why not 20 or 40? The number is not arbitrary. It's designed to cover the whole Martian surface, from the northernmost tip of Planum Boreum, the polar ice cap, to the southernmost point of Planum Australe. Each quadrangle is like a unique piece of the Martian puzzle, waiting to be explored and understood. But our understanding of Mars is not static. It's constantly evolving as we gather more data and images from various missions. In April 2023, the New York Times reported an updated global map of Mars. This map is based on the latest images from the HOPE spacecraft. This updated map is not just a novelty. It's an essential tool for scientists studying Mars. It provides a more detailed and accurate representation of Mars's surface, allowing for more accurate planning and execution of future missions. Please share this video, and it's not just about the big picture. These quadrangles also allow for a more granular study of specific regions of Mars. Scientists can focus on a single quadrangle, studying its unique features and terrain, and compare it with others. This detailed, systematic approach is what makes the study of Mars's geography so fascinating and rewarding. Closing. These quadrangles help scientists to study Mars's geography in a systematic and detailed manner. Did you know that Mars is home to the largest volcano in the solar system? Yes, that's right. Mars boasts an extensive upland region known as Tharsis, which is dotted with several extinct volcanoes. Among these sleeping giants of Mars, one stands out due to its sheer size and grandeur: Olympus Mons, or Mount Olympus. Olympus Mons is a shield volcano, a type of volcano known for its broad, shield-like shape and gentle slopes caused by the highly fluid lava they erupt. Now let's talk size. The diameter of this behemoth is over 370 miles, which is roughly equivalent to the distance from Los Angeles to San Francisco. But Olympus Mons doesn't just impress with its width. Its height is equally, if not more, awe-inspiring. The local relief of Olympus Mons, which is the elevation from the foot of the cliffs forming its northwest margin to its peak, is over 13 miles. To put this into perspective, that's a little over twice the height of Mauna Kea, the tallest mountain on Earth from its base on the ocean floor. Measuring the exact height of Olympus Mons, however, isn't as straightforward as it might seem. Due to the mountain's immense size and the complex structure at its edges, determining a definite height is quite a challenge. It's a bit like trying to measure the height of a cloud-covered mountain on Earth from a hot air balloon using just your eyes and a long measuring tape. These extinct volcanoes, including Olympus Mons, are more than just impressive landmarks on the Martian surface. They're the physical embodiment of Mars's dynamic geological past. Each layer of lava, each rock formation, and each crater could hold clues about the planet's history and possibly even hints to its future. These extinct volcanoes stand as testaments to the dynamic geological past of Mars, waiting to reveal their secrets to future explorers. From the first observations in the 1800s to the detailed global maps of today, our understanding of Mars's geography has come a long way. The early areographers, Madler and Beer, set the foundation by establishing that most of Mars's surface features were permanent. This paved the way for further exploration and understanding of the Red Planet. The features on Mars, from its craters to valleys, are named from a variety of sources, honoring scientists, writers, and towns across the globe. Mars's equator and prime meridian, similar to Earth, were defined by its rotation and an arbitrary point selection. The United States Geological Survey even divided the Martian surface into 30 cartographic quadrangles, aiding in its further study. And of course, who could forget the majestic volcanoes of Mars, with Olympus Mons standing tall as the largest shield volcano? As we continue to explore and understand Mars, who knows what other geographical wonders we will uncover in the future?